So hello guys, in this video we are going to solve this problem. So in this problem it is given that let function y is equal to f of x satisfy the differential equation x squared divided by dx is equal to y square multiplied by e raised to power 1 by x for x not equal to 0 and limit x tending to 0 minus f of x is equal to 1. Then we have to tell which options are correct. So this is multiple choice correct problem. So let's see how we can do this. So first of all, you see we have this differential equation, which is x square multiplied by dy by dx is equal to y square multiplied by e raised to power 1 by x. So what you can do, you can take this y square to the left hand side and this x square and dx to the right hand side, and you will have this. Then you can integrate both the side, and you can write this x power minus 2 as 1 by x square in this way. If you integrate, this thing will become minus 1 by y. And for this thing integration, you can substitute 1 by x as t, and then you differentiate, you will get minus 1 by x square dx as dt. So you can replace this 1 by x square dx as minus dt, and this e power 1 by x as e power t. So you will have this. So this integration is simple. So this is e power t integration is e power t plus some constant of integration. You can replace t by 1 by x, and you will have this. Now we know limit x tending to 0 minus f of x is given as 1. So for x tending to 0 minus, this y value is 1. So we can put y here 1, and x tending to 0 minus, this will become like e power minus infinity. So which is also 0. So here only remaining thing is this c. So C value we get from here as minus 1. So from here you can get the y value as 1 divided by 1 plus e power 1 by x. So this is our function f of x. Now we have to tell about this function properties. So we got function f of x as this 1 divided by 1 plus e power 1 by x. So this is our function. Now we have to tell about this function. So if you differentiate this function, you will get like this thing differentiation is minus 1 divided by 1 plus e power 1 by x whole square, and this inside thing differentiation is this e power 1 by x differentiation is e power 1 by x, and 1 by x differentiation is minus 1 by x square. So you will get this thing, and the terms in this expression are all greater than equal to 0. So we can say that this dy by dx is always greater than equal to 0, and this is an increasing function. So we can say that our function f of x is an increasing function. So now we know this. Now this is our function. So other thing we can say about this function is, if you take the limit x tending to plus minus infinity, you will know you will get here as e power 0 plus and e power 0 minus. So this is also 1, and this is also 1. So the limit will become like 1 divided by 1 plus 1, which is half. And if you take x tending to 0 plus, you will get this 1 divided by 1 plus e power plus infinity. So you will get this as infinity, and 1 divided by infinity you will get as 0. So limit x tending to 0 plus for our function is this 0. Limit x tending to 0 minus is given as half, and limit x tending to plus infinity and minus infinity, plus infinity and minus infinity is equal to half. So this is equal to 1, this is half, and this is 0. So this is given in the problem. So this we get as 0, plus minus infinity value is half, and initially in the problem it is given that x tending to 0 minus this function value is 1. So our function will look like this. How we made this graph? Because we know our function f of x is an increasing function. So for x is equal x tending to minus infinity, the function value is half, and this is an increasing function. So the curve look like this, and this will go up to 1 here. Then for x tending to 0 plus we have value 0, and x tending to plus infinity we will have this value half. So again this curve is increasing, so this will look like this. So somewhat this type of curve will look like for our function. Uh, this is an increasing function, and that's why we assume this type of curve will come for our function. Now from here you can see that our function has a range from 0 to 1, and this half is excluded because this will happen as plus minus infinity, so we excluding this value half from our range of the function. And we can also say that our function is bounded because the range only lies between 0 and 1, and this half is excluded. And another thing you can say about this function is, so first of all we can say that our range of function is this. Our function is bounded. Limit x tending to 0 plus f of x is 0 not equal to 1, so this is wrong. And the last option is, if you integrate this function from 0 to e, this will greater than if you integrate this function from 0 to 1, and this is obviously true because the nature of our uh, curve, because the e lies somewhere here and 1 lies somewhere here, so this area is obviously less than compared to this whole area. So we can directly say that this option is also correct because the integration means area. So if you integrate from 0 to e for our function, so this will be obviously greater than this thing. So in this way, the A, B and D options are correct, and in this way we can solve this.